For our Chapter 3 practice test, let's go to page 3. Page 3, back substitution. Ironically, this is a problem that is way easier than many other problems on this test. Here's why. You're ultimately looking for x, y, z. Like I said when we first began to learn this, you have the ultimate gift of knowing what one of those variables is. You'll know what z is. Go to the middle equation. 2y minus 3z is equal to 8. And now substitute in that z value of -2. Plug that in. And you can see now you have 2y minus 3 times -2 equals 8. -3 times -2 is actually just a 6. So we have 2y plus 6 is equal to 8. If I subtract a 6 from both sides, I'll have 8 minus 6 is 2. I can divide by 2 to get y is equal to 1. And I'm not done at this point. However, I am almost done. I need 3 variables. I have 2 out of the 3. I don't know what x is. So you can very quickly just get back to that first equation. This is why it's called back substituting. You're pretty much working backwards in the problem, moving upwards. And now that I know what my y is, my y value is a 1, I can plug that in. Originally, right at the very beginning, I was told that my z value was -2. And now, once you plug your y and z value in, you're virtually done. You just have to solve for x. -4 times y is -4. 2 times -2 is also going to be a -4. And combine like terms, -4 and -4 become -8. So you'd have x minus 8 equals -2. When you add an 8, you'll get x is equal to 6. But like I said earlier, you really need to write this as an ordered triple with an x, y, z, and then we're done. As we move to number 11, definitely the longest problem on the test. No denying that at all. What I hope students will pick up, though, is even though it's the longest problem that you're going to be doing, it doesn't mean that it's very, very difficult necessarily. It's just tedious. I want to point out that your z's are set up nicely so that when you add certain equations together, your z's will cancel out. Be careful. 1 and 3 won't do that. A positive z and a positive z won't help you out at all. But equation 1 and equation 2 can be combined to get rid of a z. And if we do that, you can see very, very fast that something very nice happens. X and x add up to 2x. Y and y add up to 2y. Your z's are gone. And 4 and 4 add up to 8. Now you're looking for 2 different equations that will also cancel out a z. Try equation 2 and equation 3. So you can have x plus y minus z equals 4. Down here we have 2x plus 3y plus z equals 6. And a 1x and a 2x add up to a 3x. A 1y and a 3y add up to a 4y. Your z's are gone. And 6 plus 4 would be 10. Now at first glance, this might not seem to be all that significant. That being said, I do want to point out that right now, if I were to recopy these 2 equations that we just arrived at, it's like an earlier problem that you would have had earlier on the test. In highlighted blue right now, you just say, is there some type of elimination that I can use here? Look at your y's. You can see that a common multiple between 2 and 4 is a 4. So I'm going to multiply my bottom equation by -2. And the reason why I'm doing that is so that I'll have a -4y to cancel a positive 4y. Notice 8 also gets multiplied by -2. But hopefully you can see where this is coming from. The y's are going to go away. You'll have -1x is equal to -6. Divide by -1, and you'll have x is equal to +6. Now at this point, feel free to go with either of these two equations. Maybe you want to write 2x plus 2y is equal to 8 and say, you know what, now I can plug in my x value. My x value was 6. And without too much work, you'll have 12 plus 2y is equal to 8. And I can minus a 12. 8 minus 12 is -4. Divide by a 2, you'd have y is equal to -2. So these are good things, don't get me wrong. You're dealing with two variables solved. You still need to find out what z is. And that's where now, up on the top, I'll just recopy my first equation, the equation number 1, and say, hey, x plus y plus z is equal to 4. But x is 6. Y is -2. Could we find out what z is? Well, 6 plus -2, combine those like terms, you'll get a 4. Minus a 4 from both sides. And you'll get z is equal to 0. The answer you're going to arrive at with an x, y, z is 6, -2, and 0. Finally, on this page, again, you have equation 1 and you have equation 2. You have to see if that point, -1, 2, solves both equations. When it says show work, on the test, you need to show steps by plugging in the x and the y values, checking to see if this really holds true. I'm doing that. 3 times -1 is -3. 2 times 2 is a 4. Is -3 plus 4 equal to 1? Yes. Now be careful. It's very tempting to say, wonderful, this is a solution. But we don't know if the point in question is a solution until it can be shown that it solves both of these equations. It makes both equations true. So take 4x minus y equals -6. Plug in -1 for x. Plug in a 2 for y. You'll get -4 minus 2. Is that really equal to -6? Yes. So because you get both equations having agreement on the left side and the right side when you plug in your point, you actually have a solution. As soon as one of these equations would be false, the answer would be no solution.